Alright. Today we are going to solve quadratic equations again, but this time we're going to use the quadratic formula. So you have three ways. You could graph to find the solutions, which you'll do next year. Factoring, which we did yesterday, and then the quadratic formula, which we're going to do today. Quadratic formula works every time, as long as you do it correctly. Sometimes when you factor, things don't factor out. Like when we had, all we could do the other day was take out a GCF, but if I wanted to solve something like that, then I'd have to use the quadratic formula. So the formula will work every time as long as you're doing it correctly. So those are already on the top. And your quadratic formula is typed out for you, so maybe you want to circle that or something. This is the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't know if you've seen it previously. Maybe your teachers sang you a song. I'm not going to sing you a song. Do you have to memorize it? Yeah, you have to know it. Did she sing you a song?
Who did?
Did it go like X equals negative b? Yeah. There's dance moves to it. Yeah, no. So, yes, you have to know this. If you ever need to use it on upcoming quizzes and tests, I won't give it to you. You have to know it.
Cruel.
Cruel, I know. The A, B, and C, those come from your quadratic equation. So you have to make sure all these equations are set equal to 0 before you can start the quadratic formula. The A value is always the number that's in front of the squared term. B is always in front of just the x. And then C is whatever the number is that's left over. So to number 1. 7x squared plus 6x minus 1 equals 0. I've got it set equal to 0. So then I want to find the A, B, and C values. What would be the A value of this quadratic? 7. Good. And B would be, and C would be negative 1. Watch your signs. Whatever's in front of it, make sure you keep it with it. You have yours typed up there, the quadratic formula. So all it is now is substitution. Some people say negative b, that's what I like to say. Others say the opposite of b. So at the beginning where it says negative b plus or minus, you actually have to put the opposite of the b. So ours is going to start with negative 6 plus or minus the square root of b squared, so 6 squared, minus 4 times a, which is 7, times c, which is negative 1, all over 2 times a, or 2 times 7. Once you substitute them, then it's your algebra skills, you're simplifying, working inside out. Inside of here, what is 6 squared? 36. And then when you read it out loud, it's b squared minus 4ac. So when I keep this minus here, then I'm going to take 4 times 7, which is 28, times negative 1, which would give me negative 28, right? All over 14. There's two ways you can look at that. You could think of that as a negative 4 being multiplied across, or you're subtracting 4 times whatever those other two numbers are. Inside of your 36 minus 28 becomes what? 36 plus 28. Whenever you subtract a negative, it becomes positive, and 36 plus 28 is 64. So we have negative 6 plus or minus the square root of 64 all over 14. Is 64 a perfect square? What's its square root? I think this is really like negative 6 plus or minus 8 all over 14. When you have a quadratic equation, how many solutions do you get? 2. It comes from negative 6 plus 8 over 14. And then the second solution, negative 6 minus 8 over 14. You have this plus minus there. Because whenever you take the square root of something, there's actually a positive and a negative value. The square root of 64 is 8 and negative 8. So the quadratic formula takes care of that by already putting a plus minus in for us. Simplify across, what's negative 6 plus 8? 2, and 2 over 14 would become 1/7. Negative 6 minus 8,
Negative 14.
and negative 14 over 14 would be
Negative 1.
negative 1, right?
Wait, do we have to plug those, or like, do we have to set those equal to 0 and then subtract them?
These are your solutions.
Okay, I couldn't remember.
Yep, these are your two solutions. Bless you. Like yesterday, you can check these answers by substituting them back into the equation. I'll just do negative 1 here. So if I put negative 1 back into the original,
So why don't you just set those ones equal to 0 like the ones we did yesterday?
hang on. Negative 1 squared is 1, right? And 1 times 7 is 6 times negative 1 minus 1 more. Well, 7 minus 6 is 1. Minus 1 more would give me 0. Okay, your 1/7, you could plug that into the calculator. If they don't come out as nice whole numbers or fractions, then round your decimal to the nearest hundredth. Okay, and it says that in the directions, round to the nearest hundredth. The work I want to see. You gotta show me the A, B's, and C's that you plug in. I want to see that step. And I want to see this step, what it looks like after you have that all simplified. Where I have negative 6 plus or minus the square root of 64. If you don't want to show me this 36 minus negative 28, I'm okay with that. You don't have to show me that work. And if you really don't want to show me this, what I have here, negative 6 plus or minus 8 over 14, I'm okay with that too. But I need this in red. That's the minimal work I want to see. See? Alright. For me, I don't set these ones equal to 0 because I'm setting it equal to x already. I already know x is going to equal all of that. Okay. Alright, let's try the second one there. Negative 3x squared minus 5x minus 1 equals 0. Set equal to 0. So now we need to find our A, B, C values. What would be my A value? Negative 3. And my B value? And my C. Good. So you have it typed there for you, but it's x equals negative b. So should I put negative 5 or positive 5 out there? Positive 5. Good. It's the opposite of what you've written down. Plus or minus the square root of b squared. So we're going to put negative 5 squared in there. Minus 4 AC all over 2a. So I want to see that step. Then when you work inside out, you don't have to show me that one. But the next line I would want to see then is 5 plus or minus the square root of 13 all over negative 6. You should get 13 underneath the square root symbol when you simplify that. Is 13 a perfect square? No. So you're going to need your calculator here in order to find your two solutions. If it's not a perfect square, then you're going to have a decimal answer. So one of them, you'll punch in 5 plus the square root of 13 divided by negative 6. And then the other one, you'll do 5 minus the square root of 13 divided by negative 6. You have to be careful with your calculators. You must watch your parentheses. For the first one, when you add the square root of 13, you should get negative 1.43. If you don't get that, try again. Make sure you know how to use your calculator. When I punch it in, I do it as two separate things. I do the numerator first, so I just do 5 plus the square root of 13, enter, and then I divide by negative 6, because that takes care of having to worry about parentheses then.
Do we have, like, if we just left it as 5 plus the square root of 13 minus 6, would we get docked one?
Yep, because the directions say round to the nearest hundredth. Sorry, Remy. And then your one, when you subtract the square root of 13, you should get negative 0.23. It's your responsibility to make sure you know how to use your calculators. If you need help, I'll help you, but don't wait until a quiz day to figure it out. Questions on that second one? Okay, flip it over. I want to do number 5 with you too. I think number 5 is this, right? 6x squared plus 10x equals 5? Okay. Can I find my ABCs right now?
No.
No, why not?
Because you have to have it set equal to 0.
Good, I have to get this thing set equal to 0, so how do I move my 5 over?
Subtract it.
Subtract it over. So then our quadratic in standard form would be 6x squared plus 10x minus 5 equals 0. You have to have them set equal to 0 to start. Now that it's to 0, what's my a value? 6. My b value? And my c value?
Negative 5.
Negative 5. Good. And you're just substituting it back into your quadratic formula. The more you write your quadratic formula down or just say it in your head every time, the better you're going to remember it. X equals negative b, so negative 10, plus or minus square root b squared plus u minus 4. Okay. See? All over 2a. So I want to see that step. Plus u. I get negative 10 plus or minus the square root of 220 all over 12 then. If you look at how many negative symbols you have, that's going to tell you if your number will be positive or negative. And I'm including 4 this time. So 4, I'm going to say is negative, and 5 is negative. So a negative times a negative will always be positive. Okay, so this 120 should be positive. This value underneath of here where I have 220 should never be negative. If you get a number under the square root symbol and it's negative, you either substituted your ABC in wrong or you just didn't multiply correctly. So that's one way to check is that number underneath the radical, the square root symbol, needs to be positive. 220, is that going to come out as a nice square? No, it's not a perfect square. So then you're going to need to use your calculator and take negative 10 plus the square root of 220 divided by 12. And then negative 10 minus the square root of 220 divided by 12. So I got 0.4 and then negative 2.07 when you round that to the hundredth. So these ones that come out as decimals means I wouldn't have been able to factor them like we were doing yesterday, but I can still find the 2 solutions. When you check your decimal answers, when you substitute 0.4 back into your original equation, it's not going to come out to 0 exactly because this is an approximated answer. So if you check your decimal answers, your calculator should shoot out a number really close to 0. They just won't be 0 exactly. Whole numbers and fractions will come out to 0 exactly, but decimals won't because it's a rounded answer. Questions at all? Okay, the rest of the worksheet is your assignment then. You have 11 problems to do, and you have the rest of the class period to work on them. It'll be due tomorrow. Tomorrow we are going to do a worksheet over factoring and the quadratic formula. So it's just more review tomorrow. All right? All right.
Yep, one second, let me stop this.